mechanism that we are going to be talking about today is the thiazolium salt catalysis and aldehyde coupling. Thiazoles are heteroaromatic compounds with nitrogen and sulfur through alkylation of nitrogen, which then forms the thiazolium salt. We use this thiazolium salt combined with two aldehydes to form an alpha hydroxyketone. The reason why this can happen and what actually drives this whole reaction to occur is the fact that there is an unusually acidic hydrogen in between the nitrogen and sulfur heteroatoms that has a high pKa of 17 to 19.
Okay, so this is the mechanism for the thiazolium salt catalysis, and the first step is deprotonation, which has to occur at a super high pH because this hydrogen right here has a pKa of 17 to 19, so like something like pH 12 is good. So the first thing that happens is the hydroxide kind of grabs the hydrogen, and that gives you the water at the end, and then several resonance structures form from there, and it is deprotonated.
So after deprotonation, we have nucleophilic attack by a catalyst, and this is the deprotonated thiazolium salt, which acts as a nucleophile and attacks the carbonyl, which then moves its electrons up to the oxygen to obey the octet rule. And then we get this, which has an unstable oxygen, so it takes hydrogens from the water that we created in the first step, and then we end up with this intermediate with a hydroxide as a byproduct.
The next step is forming an acyl anion. So what happens is that the hydroxide group that was generated in the previous step will deprotonate the intermediate in order to form an acyl anion, which is more stable than the current intermediate that we have. So when the hydroxide attacks this hydrogen, the hydrogen will give its electrons to carbon, and then it can participate in resonance. So in order to do that, the electrons that are on this carbon can form a double bond, and then this double bond in between the nitrogen and the carbon will give its electrons to the nitrogen, thus forming this. However, for the next step, we are going to be using this version of the acyl anion because we need the electrons on the carbon in order to act as the nucleophile and attack the electrophile.
So here we have the acyl anion from the previous step, and it's reacting with the second aldehyde, and the acyl anion acts as a nucleophile and it attacks the electrophilic carbonyl here, and then it forms this intermediate where once again we have an unstable oxygen. So this oxygen attacks the water group that we formed, and it pushes off a hydroxide and results in this intermediate.
The last step is to form the alpha hydroxyketone, which happens by the hydroxide taking the hydrogen from the nearest carbon next to the thiazolium substituent, and you don't want to take this hydrogen because then you won't be able to form the hydroxyketone. And so once you take off this hydrogen, you form this unstable oxygen, and that eventually forms a double bond which kicks off the alpha hydroxyketone, and you're left with this, the alpha hydroxyketone, and the two reactants that you started with, which is why it's a catalysis of the thiazolium salt, because you're left with the two reactants at the end.